What's up, Robonauts? Kylie Blake from Robocorp here with another episode on our regular Coding for Success video series. Today we'll be talking about why testing is important for our robots, when to test, and how to write effective tests. So let's dive right in. So why do we test our robots? It's a lot like writing anything. We're human and we make mistakes. Even our robot and AI friends can make mistakes. So testing allows you to catch those mistakes, and the sooner you do it, the sooner you can fix them. Especially for beginners, learning how to test your own code is crucial so you get that early feedback on whether that keyword or function you just wrote does what you expect. But it's not just for beginners. Advanced developers often follow what's called the test-driven development strategy, where they execute small iterations of the red-green refactor cycle, but we'll talk a little bit more about that in a moment. On top of that, writing small unit tests and small functions that get those tests to pass helps break problems down into smaller pieces, making it a lot easier to accomplish the overall goal. But of course, if you don't test your robots, you run the risk of introducing bugs or errors that could cause the robot to fail or behave unexpectedly. And you may not notice these bugs until much later in the process, when it's a lot harder to change your approach. All of this translates to higher quality robots, increased productivity, and if you know how each function works before you plug them in together, you can focus on individual problems as they arise instead of trying to debug the whole thing all at once. So, when to test? Well, it's easy. First. Now, you might be thinking, but wait, how do you test something that doesn't exist? Well, that's where the whole idea of the test-driven development comes in. In fact, you write the test first, just like this one, actually. So you can see here I have an import, and I have, I'm using the Pytest framework. This is a pure Python robot, but for the sake of simplicity, I'm going to walk through this relatively straightforward example for a web store. So what's the first thing you might want to do in a web store? Well, let's say add an item to a cart. So pretty much normal test strategy, arrange, act, assert. We've got the cart object, we start it. We have the item object, we initialize it with a banana and a 1, so it's a $1 banana, I guess. We add that item to our cart, and then we double check that the cart actually has the item in it. Cool, great. The test is written, it's going to work, right? Well, not so much because we've not written any code, right? So now you have a test that represents sort of your requirements and what you need to do. So now you can go and write the code. And so I just so happen to have the code ready here. So you'll notice that my branches are called red flag and green flag. That kind of represents the whole stages that I was just talking about. So let's load the green flag. This would represent sort of your implementation of that cart and item objects we just talked about. So I will go ahead and open the new cart file. It's relatively straightforward, but of course, your robot would be a lot more complicated with specific functions. But again, start doing it from the beginning with smaller pieces. So take one requirement and build the test. Take another requirement, build the test. For like a web store, the automation, you might want to start with like the login function. So write a test to test the login function and then write the actual login function. So that's sort of your red-green refactor cycle that I talked about earlier. And so this represents the green flag, a basic implementation of cart, add item, get items, as well as the item itself. This matches our test and how we initialize them. So by writing the test first, you kind of have an idea of what you're going to do, and then you can do it, and you can keep the implementation very specific to what you need to do instead of starting to sort of add and add and add, and then you get so much complexity you can't even keep track of your own stuff. So if you keep it really focused on what you need to do, write a test, implement it, what you need to do, write a test, et cetera, through that cycle, it's going to simplify your process a lot. And so you'll see here now I've got the cart, we've got this test, now I can run it and it will pass. Of course, it was a relatively straightforward. Hopefully yours passes in the first time. It might not, but that's sort of the whole process of creating tests, writing code, creating tests, writing code. And you'll get kind of used to that back and forth. And so now the next step let's say you could write a few more tests and a few more functions. You could also refactor your function because maybe as you wrote the test and maybe as you wrote the cart file, you're like, oh, you know what? There's some other things I could do here to make the cart more useful. So maybe you write those functions, and that's called the refactor side of it. And so with that, I'm going to load the completed example, which is the full refactoring. So maybe I thought removing an item is a good idea. So we've got removing an item there. So now you could then write a test here to test your removing. It might fail, it might succeed. You go back and forth. But always remember that when you add functions, you definitely want to have a test associated with them so that you can be confident that that function works, especially as you get more and more complex and there's a chance of adding regressions, which is to say bugs you didn't expect because you added something somewhere else and something else doesn't work anymore the way you thought it would. That's kind of like the regression error or bug. And so like by doing this process and then having in VS Code especially, we've got the whole testing suite built in. This also interfaces with Robot Framework files. It can find these. So you can run tests against your user keywords, against your Python functions, your Python libraries, all the different things. Like there's a way to do a unit test for everything. And I'm not going to go into every way of writing every single test. I highly recommend you do a little bit of Googling out there and check for like look up how to do Pytest, look up how to do Robot Framework code tests, and just see what you can make work. And then later, when you've got the robot and you come back to it in like a month, you'll be able to run those tests again, see how it worked, and then start implementing more stuff to it. And that's a really great way to not only sort of like document as you go, but also figure out how things work. And so I use that myself a lot in my own development, is writing the tests, checking my own understanding, digging into the code, looking at other people's tests of libraries I'm using helps me learn an awful lot. And so that's really that's the most basic red-green refactor cycle. Do it for every unit test. Once you have all your unit tests, maybe you start doing integration tests where you test the entire login, add things to a cart, store them, sign out, order them. In fact, whatever business processes, you do a full integration test. You can add that to the test suite. And as you're building up tests, especially like things with Pytest, which allows for fixtures, or Robot Framework, which has like the user keywords and the user variables and the global variables, you can build a large test suite that can use one thing all the way through. And so with that basic understanding and the basic kind of what the code would look like for an example test, I'm going to go ahead and stop showing that and kind of just talk through some of the more important pieces of how we test and what's important to test. So like I said, creating a test can be as easy as writing two separate files you saw right there, one that's full of functions or keywords testing your robot code, and one that's the robot code itself. Or you can get a little more fancy, like I kind of started to talk about. You can start using packages like Pytest. You can start using Robot Framework stuff. You can use test frameworks. There's many different types of test frameworks. You can be used directly to perform tests. I actually find a lot of value in using some of those new AI tools that you might have heard about, like ChatGPT or GitHub Copilot. If you give them the context of your code, they're very good at coming up with new tests and helping you find regressions. And so now a few more very important things to keep in mind. Do not test against live systems. Kind of a sort of a basic tenet of programming. You don't want to test against production and break production. You'll get in trouble. I actually did that once, so don't do that. So usually a robot's automating something, so you can test your robot using a test version of something, hopefully, so you don't break anything important. But I have had an experience where you have to automate a system that doesn't have a test version. So just when you do that, be super careful about the actual actions you're automating. So like if there's a final step that confirms a form, just don't ever click that, So just be careful with what you are automating and what the target is. Preferably always use a test system. And so, like I said, write small unit tests and small keywords. Try to write as compact as possible. The smaller the function, the smaller the namespace, as I like to refer to it, and I know a lot of people other do as well. But the smaller that namespace is, the less you have to like keep in your head and keep track of what's happening as you actually coding. And so that smaller namespace helps make the problem space smaller. Smaller problem space means that you have to think through less. And so if you can do smaller functions and think smaller in smaller areas, you can make a big problem into a bunch of small problems, which is easier. And so also, don't write a bunch of tests before you write any functions. So one sort of like hiccup that can happen with test-driven development is you can start to write a test, like, oh, I can test this, oh, I can test that, ooh, I can test that. You start to like think of all these different tests, and that's not really test-driven development. You want to write one test that is based on one requirement, and then immediately write the code for it to get it to pass. And then just go back and forth, back and forth, back and forth, doing that cycle. And so that's very important. That really helps drive the productivity, and it helps drive collaboration, because if you do small functions and another person's working on the project and they're doing small functions, then eventually all your small functions can kind of come together into one big automation or program or whatever it is you're building. And like I showed a little bit, I do really recommend using a framework that helps you collect test results and review them. And a lot of them have sort of introspection, so they can look into your code and see what errored, like what specific line item errored. Especially like Pytest and Robot Framework both do a really good job of building logs and reports, so you can look at them and be like, oh, it's exactly that line that broke. Okay, did I not realize I needed a list here instead of a dictionary, or like whatever it is? It's really easy to mess that stuff up, especially in Python. So frameworks really help generate those reports and help you look into, what happened and what you can fix. And, with that, that's sort of the basics of testing. So in conclusion, testing your robots is super important, part of your development workflow, and I highly recommend you do it first before getting too deep into any one bot. I know that it's easy to just start coding out bot functions or bot steps, but like I really recommend trying to do a test first and then pass that test. Tests can be short and sweet, still provide a lot of feedback to you as you develop your robot. They don't need to be super complex. Whatever it is you want to do from a small requirement standpoint, it will really help you think through your problems, break them down, and then eventually create something super complex. But in each piece is really straightforward and small in your own head, so you don't have to try to take in all the complexity all at once. So that's the basics of testing, and I really hope that helps you out. So thanks again for tuning in to this episode of Coding for Success. Don't forget to like and subscribe, and see you next time.
Robocorp, where the world comes together to automate.